Hi everyone! In this video, I'm going to provide an introduction to working with the Pandas Python library. You can see on my screen here that I have the Pandas website pulled up, and on this website, it describes Pandas as a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. If you're going to be working with data in Python, perhaps as part of a data science or machine learning project, then you'll probably want to take the time to learn Pandas because it will save you time in the long run. You'll often be loading data from a file, doing some processing like cleaning or visualization, and then writing the modified data back out to file, and Pandas is really great at all of these tasks. It's also built on top of NumPy and interfaces super well with other libraries in the Python data science library ecosystem. So learning Pandas is really unlocking the ability to work with other libraries in Python seamlessly and quickly. Before we head over to our dev environment and start writing some code to play around with Pandas a bit, I would like to recommend the first recommended book on the right side of the website here. So this is Python for Data Analysis, written by Wes McKinney. And Wes McKinney is the original author of Pandas. I came across this book when I was self-teaching data science and machine learning when I was in graduate school, and I read the first edition cover to cover, and it was immensely helpful to see all of the really useful Pandas functionality in one place. A lot of times, I didn't even know I would need something, but I'd learn about it here, and then later pop in my mind like, oh my gosh, I can just use that really nice, syntactic sugar that I learned in this book to do this thing that would take me several lines of code to do otherwise. So just a quick shout out for that book. If you're looking for a resource to continue learning the details of Pandas beyond some videos like this on YouTube or whatnot, definitely recommend that book. All right, so I'll be using VS Code for my dev environment. You can see here that my current working directory is a simple folder called Pandas Fun that just has one main.py file that I'll be working in here. I highly recommend that you get organized like this because in subsequent videos, we'll be working in Pandas Fun, and we will be creating some files with tabular data in it that will be loading into Pandas data structures and then modifying and writing back out to file. So it's just nice to stay organized with a current working directory like Pandas Fun. You will need to install the Pandas library in your Python environment. It is not a standard Python library. So unless you're working with, say, like the Anaconda Python distribution, like you can see that I am over here, you will need to install it. So go ahead and do that now, like a simple pip install in your terminal, or however you've been installing your Python libraries that are non-standard up to this point. That will work for installing Pandas as well. Once you've done that, let's check and make sure that we're able to import Pandas. So just really simple import statement. I run this and see that we do not crash and we make it to line 2. So awesome. We are good to go with importing Pandas in this simple main.py script. So I'd like to take a little bit of notes here about why Pandas. I mentioned earlier working with data, in particular, maybe working with tabular data, which is data that, you might often see in like an Excel spreadsheet organized into rows and columns. We already have data structures and functionality in Python for working with data like this. Why do we need Pandas? Well, let's think about tabular data for a moment. Data, say, that's in like an Excel spreadsheet. So that data is two-dimensional, right? We have rows and we have columns. We could store that data in a, say, 2D list. But there are a few shortcomings of storing that data in a 2D list. Let's write them down here. So the first shortcoming is it's actually a lot of work to get a column out of the 2D list. It's pretty easy to get a row, right? You can just index directly into the table, like table sub 0, and that will give you the first row. But what if I want like the first column or the last column or an arbitrary column based on, say, column name stored in a separate header list, right? I'm gonna have to figure out, okay, what is the index? What is the location of that column name in the header? Then I'm gonna have to go through every single row and I'm gonna have to grab the value at that index in the row, append it to another list to build a one-dimensional list that represents the data in that column. That's a lot of work. With pandas, we won't have to do that. We won't have to write a loop to iterate through and grab all the values in a column. We'll be able to grab columns like we grab rows directly. Second, there is a lack of what's called label-based indexing when working with lists. We know we can grab items in a list by position, right? Like I said earlier, if I want to grab the first row in a 2D list that represents a table, I would just grab index 0. That'd give me the first list, the first row. But what if each one of my rows has a nice label on it, perhaps like a participant ID or a participant name? Or let's think about columns. Let's say every column has a nice name to it. Perhaps, for example, a timestamp or a total. Then we'd want to be able to just use those strings, right? Those row or column names directly to grab data. We can't do that with lists, but we can do that with pandas. So in pandas, there's two main data storage objects that we use. So the first one is called a series, and this is for one-dimensional data. So you could think about this like a 1D list for a row or a column that has a lot of great built-in functionality like label-based indexing, even, calculating some statistics, visualization, etc. Secondly, the DataFrame. The DataFrame is for storing 2D or really ND multidimensional data. So each row or each column in a DataFrame can be thought of as a series. And the same functionality for series that I just described applies to data frames. There's some built-in functionality like doing some summary statistics or doing some visualization that you can call with methods straight on data frames. They're super, super, super powerful, and you're going to love learning them. So we'll start slow and we'll work with series. So first, we're going to need some data. It doesn't really matter what data we work with right now, so feel free to use any data you'd like. I'm going to use simple populations for cities in Washington State, which is where I live. So I'm going to grab these values from this website, Washington Cities by Population. So let's do the first two. Let's do Seattle, Spokane, then perhaps let's do Bellingham, and then we'll grab a much smaller city like Pullman. So 764,753. We'll have a parallel list here, which will have the names of the cities that these values correspond to. 229,608. 96619. And then let's do Pullman. 32868. 32868. So notice how I have two lists here, right? The first one stores my numeric data values. The second one stores some metadata about those values, right? Some contextual information about them. I mean, I could just grab, say, the Seattle population by indexing into pops with, say, pop sub 0, right? That will give me the population for Seattle, but there's no context to the 0 here, right? I have to look up this 0 value in this parallel list cities. So series is actually going to tightly couple this label-based information for this numeric data into one data structure and allow us to use the more user-friendly, more readable Seattle label as the index instead of the integer position 0. So let's make our first series. I like to put ser in the name of my variables that correspond to series objects, because that way I can just look at this and know this is a series. This is one-dimensional. I know how to work with this. So we'll invoke the initializer for pandas series with pd.series, and then we'll have to pass in our data and optionally an index. So our data is pops and our index is cities. So if I print this out, this is the output that I see here. So the actual data is in this column here. The index, or the labels that can be used to uniquely identify the data values, are on the left side here. And you can see that Pandas correctly inferred the data type for the data of the series. Okay, that's this value, or this column of values here, as int64. Now let's say I don't include cities as my index. Pandas will just give me this standard default 0-based index. And we can always use 0-based indexing to grab values from a series, even if we have a nice label-based index provided like we have here with cities. And that's what we're going to see here in a moment when we start indexing. But before we do, there's one more thing I'd like to show you, which is you can name your series. So let's say I name this series population. You can see now there's some additional metadata about the series printed out here, name population. Okay, I like doing this in case I'm going to be working with this series and DataFrame. For example, if I were to go try and build DataFrame using a series like this, then population would be the name of the column in that DataFrame. Or if you were to index into a DataFrame with the name of a column like population, the series you would get would be named population. It would be named the same as that column. And we'll see that here in a moment. So now time for indexing. So first, let's say I want to get the population of Seattle. I can write this really user-friendly print popser sub Seattle, and it will give me the population for Seattle. That's a lot more readable than something like, list sub 0. I will show you though how you can use integer index position-based index here in a moment. So next, let's see how we can do some slicing. So let's say I want to get all of the populations from Seattle to, say, Bellingham. Now we're used to, this slice operator syntax always being inclusive of the starting index and exclusive of the stopping index. But interestingly enough, this produces a subseries that includes Bellingham, which is our stop value, right? Our stop index here. So just make a little note that this is inclusive of the stop because it's doing label-based indexing. That's not going to be true when we do integer position-based indexing, which will be more familiar to what you're used to when you do, say, slicing with lists and tuples in Python. I can also just pass in a list of labels to index. So let's say I want Seattle and Bellingham only. I don't want to slice from Seattle to Bellingham. Oop, got to spell Bellingham right. Then this is going to give me a series with just the subset of data corresponding to Seattle and Bellingham. So this is already more readable than something like 0, 2, and we wouldn't even be able to do this with a Python list, right? We wouldn't be able to pass in a list of indexes to index into the list. So hopefully you can see already how powerful this is. So next, let's see how we can use something called iloc for position or integer-based indexing. So let's say I want to do line 21 again. I want to print out the population that corresponds to Seattle, but I'm not going to use the Seattle label. I'm going to use its position. So maybe I know that I just want to get the population for the first city, which happens to be Seattle, but let's say I just know I want the first one. I could do popser iloc 0, and that's going to give me the same output as using the more readable Seattle label. But I might just want to grab the first one, whatever it is. Let's also see slicing with iloc in action. So I'm going to slice from 0 to 2. However, note that this is going to be exclusive of the stop because we are doing position-based slicing. So this gives us the values for Seattle and Spokane, but note that it's exclusive of Bellingham because we're doing integer position-based indexing here. So just something to keep in mind. And then let's do the same thing as line 23. Let's say we want to get the values at index position 0 and 2. So that should give us Seattle and Bellingham in a series. And it does. And I'm seeing tons and tons of typos here. Sorry about that. Okay, so there's some very, very basic indexing and slicing with Pandas series. Let's now take a look at some of the built-in functionality, like for example, summary stats. Let's say I want to figure out what is the average population of all of the cities in this series. With Pandas and series, this is just going to be like very simple one-liner. So I'm going to print out popser.mean. And there it is. That's the average of all, only 4 in this case, but you could imagine if all of these cities, 633, were in this Pandas series. So all of the city population values. And there's tons of other statistics and functionality in here. Like here's the sample standard deviation. To see all that Pandas has to offer in terms of series and soon DataFrame methods for operations like this, you can go to the Pandas website, hit documentation. You can go to getting started in user guide, but I'd recommend if you're ready, go straight to the API reference, and you can see on the left side all of the different options for getting started with learning more about Pandas. So for example, plotting. I mentioned earlier that there's some visualization built into Pandas that's built on top of Matplotlib. So here's the API for that right here. 2 little things I want to show you related to the basics of series, and then we're going to move on to data frames. So first, we can add a new value to the series, much like we add a new key value pair to a dictionary. So let's say we want to add another city. Let's grab one. I landed on Bothell. We'll do Bothell 51575. So this is the same syntax that we would use to add a new key value pair to a dictionary. If I print out popser now, you can see that Bothell has made its way into the series. And note that it goes at the end. So there is order to a Pandas series, unlike a Python dictionary, which has no order. Next, we can also make an empty series. You'll just want to make sure that you tell Pandas what the data type of the values, not the index, but the values in the series is going to be. So I'll just call this popser2 for simplicity. And I'm going to tell Pandas that this should be a series with integer data type. And I'll do the same thing I did up here. But just with pops there too. So you can see this is a different series because it doesn't have Seattle, Spokane, Bellingham, Pullman in it. It just has Bothell in it, and the data type is an int64, which is the default precision for this simple int that I provided in the constructor. All right, so that's the basics of series. We're going to do the basics of data frames. We'll do indexing and slicing, and then we'll stop this video. And if you're interested in learning more about working with data frames and series, then I'll encourage you to check out the next video where we will really see the use cases of pandas in action, like loading data from a file. So same as with the series, we can make a data frame from a list, but this is going to be a two-dimensional list because, as we learned earlier, data frames are for multi-dimensional data. So you would simply just have a list like 2D list, and each one of the items in the list would represent a row in your data frame. So I'm just going to make up some values here. Okay, there's no rhyme or reason to what I'm putting in here. Right, so this is a 2D list with 3 rows and 2 columns. And let's say I want to make a data frame from this. I like to name my data frame variables with df in them. So I know, this is data frame versus like ser, this is a series. So pd.dataframe, and I simply pass in the data, 2D list. I can also pass in some additional information. Perhaps I have labels for the index, which would be the rows. I might also have labels for the columns, which would be my column names. Let's just do 2D list for now. We'll pass in the data and see what the default row index and column names look like. So you can see, we get this really, really nice grid pretty print from printing out a data frame. This is really nice for debugging purposes. And we get 0, 1, 2 for our default row indexes, just like we saw earlier with the default row indexes when we were first printing out our Seattle, Spokane, Bellingham, Pullman population series. And then we also just get 0-based default indexes for our columns too. But we can override that. So when I make my data frame, I can pass in a list for the index. So for example, like row 1, row 2, I'm just making this up, row 3. Okay, the dimension of this better match the dimension of your outer list. And then I can also pass in columns like column 1, column 2, just making this up. Same thing here, the dimension of this list should match the dimension of each of your inner lists, right? So this is a 3x2 table or matrix here. 2 because each one of my rows has 2 values in it. So I should have 2 strings or 2 labels for my columns. And now you see there's more contextual information here. Granted, I just made up these values, but hopefully you see how we could perhaps build something more interesting related to our population data or the data that you plan to work with for your own projects. So now would be a good time to actually pause the video and try making a data frame based on our very simple population series data. So let's say make a data frame for our city population data. As is, this would be a data frame that only has 1 column, right, for the population values, which is fine. You can have a data frame with 1 column, but perhaps it would be more interesting if we had a few more columns. So we can have the city name be a column instead of being the index. And you can also add perhaps a size column. So this could be something like small, medium, or large. Just go ahead and make up assignments for our cities here. I mean, they're kind of in order, at least until we added Bothell. Seattle and Spokane are large, Bellingham perhaps is medium, Pullman small. So pause the video and try to make this data frame. So here's my two-dimensional list. So the first one, Spokane, or I guess I have Seattle first. Seattle, 764753, and we'll call this large. Now we have Spokane, 229608, large. Bellingham, 96619, medium. There's no real science behind these assignments here of small, medium, and large. 32868, small. I'll call my data frame PopDF, more specific than just DF. This is my population data frame. Maybe even city DF would be a good name. And this is going to be a data frame, and my data is pop data. And then I'm going to pass in for my columns, city, population, and size. So I'm not going to pass in an index, so we'll just get the default 0, 1, 2, 3 integer position-based indexes. But what I can do after I've made the data frame is I can say, oh, hey data frame, one of your existing columns is actually going to be your index. So I can do popdf is assigned, is overwritten, popdf with the city column set as the index. So now I do this, notice that it looks a little different, okay? Before city was the first column, the label was up at the same height as population and size, but now it's slightly smaller, and that's kind of denoting that city is the name of the index, and the index is Seattle, Spokane, Bellingham, Pullman. So these should be unique, right? Your index should uniquely identify your rows in your data frame, much like, say, a primary key identifies the rows in a database table. So this is optional to do this, but I always like to have the additional contextual information embedded in my data frame. So if I do have a column or a couple of columns, if you want to learn about hierarchical indexing, that can uniquely identify my rows, I'm going to make them into my index so that I can use those nice labels to grab rows in a more readable fashion. Okay. You're doing awesome. We are going to do a little bit of indexing here, and then we'll call it good on this introduction to Pandas data structures, series, and data frames. So first, let's see how we can grab a column. So recall that if I grab a column out of a data frame, it's just going to be one-dimensional, and that's going to make it a series. So I'm going to save. Let's do the population column in a variable called popsar, and then I'll just print it out. And that's it. That's the syntax here for grabbing a column. Note that this is going to be looking for a column named population, not a row index named population. I will show you here how you can grab a row by label. So let's say I want to get the Seattle series. So what I'll do is popdf.lock. Okay, so the .lock is going to be row major. So I would first specify a label for my row index. So this would be Seattle. And I'll make a little note here. So look at that. I have a series that just stores all of the population size information for Seattle. Okay, so I'll just repeat this syntax, direct indexing for columns using a label, and this syntax with .lock for direct indexing into rows using a label. So same thing for using ilock. You can use this for row or column-based indexing. Let's do the Seattle SARE line 64 again, but this time using position-based indexing instead of label-based indexing. So this would be popdf.ilock0. This should give us the exact same series again, just showing a different way to get it. Looks like it matches. But if I want to do pop SARE again, so I want to just grab the population column from the data frame, then this means I have to grab all of the rows. Okay, so just our slice operator with no start and no end to grab all of the rows. So then I grab the position of the population column, which is 0. And this should be another way to do line 61. And there it is. And I can use .lock and .ilock with 2 labels or 2 indexes to get a single value out of the data frame. So let's say, for example, I want Seattle's population, then I could do, say, popdf.ilock00, and this should give me the 764,000. That is the population of just Seattle. So that's really cool, right? So remember, if you grab all the values in a row or all the values in a column from a data frame, you're getting a series. And then the same indexing, same slicing, same functionality that we saw up here earlier for series can apply. So let's say I do .ilock0 to get the population series, then I could do .ilock again on that, say to grab the first or the last or something. Then I could also call .lock on it as well. .lock will just do the label-based indexing that we're familiar with on series. This is a good place to stop. We covered a lot in this video, including why pandas, how to create one-dimensional panda series from list data, and how to create two-dimensional pandas data frames from two-dimensional list data. And then we saw some indexing and slicing and built-in functionality in action. Stay tuned for the next video where we're going to start working with data in files and some data aggregation like group by. That's it. Thanks for watching.